We may have dramatically underestimated the number of habitable planets in the universe, because we haven't considered the role played by ocean circulation, according to new research. Until recently, computer simulations of habitable climates on distant Earth-like planets focused on their atmospheres, and any consideration of their oceans assumed they were similar to ours. But scientists have now taken another look at the alien atmospheres to include the effects of oceans, and they have discovered they can boost the likelihood of them being able to support life. The number of planets being discovered outside our solar system is rapidly increasing, and we assume that many will be uninhabitable because they are either too close or too far from their sun, said Professor David Stevens, from the University of East Anglia. Writing in the Proceedings of the National Academy of Sciences today, he explained, "Oceans play a vital role in sustaining life and also have an immense capacity to control climate." But previous studies on ocean circulation on other planets have made the assumption that fundamental ocean properties, such as the salinity and depth of water, would be similar to that on Earth. Here on Earth, water warmed by the sun in the tropics moves north or south towards the poles, where it cools and sinks before returning at depth towards the equator. But bodies of water on alien worlds may not necessarily have the same salinity levels, which could cause them to act very differently. The researchers modeled exoplanet oceans with very low and very high salinity, similar to freshwater lakes in the Dead Sea, to see what difference this would make. And they discovered it would make a very big difference indeed. Dr. Manu Joshi, from UEA added, oceans on planets with a much higher salinity could circulate in the opposite direction, with polar water flowing towards the equator at the surface, sinking in the tropics and traveling back towards the poles at depth. We found a similar pattern for freshwater oceans. These circulation patterns, the opposite of what happens on Earth, would result in a dramatic warming in the polar regions of exoplanets. Fellow researcher Jody Cullum added, on any given exoplanet, many other properties are likely to differ from Earth, and some of these may also influence ocean circulation, tidal forces, planetary rotation, ocean depth, and the location of continents. But this will help us understand the habitability of distant planets in more detail than ever before. On Earth, the circulation of salty water is called the thermohaline current, of which the Gulf Stream is a major component, and is the engine which distributes our ocean's heat and nutrients around the planet. Combined with our distance from the sun, not too close, not too far, and other factors, it makes conditions suitable for supporting life. Disruption of this engine is one of the many nightmare climate scenarios which could dramatically shift Earth's climate, causing northern regions to cool. But on distant exoplanets, which may have been thought as too far from their parent star to support life, saltier oceans mean that sea ice is less likely to form. Less global ice coverage would mean a warmer climate, and so would expand the range of the habitable zone around a distant star, which could potentially provide the right conditions for life.